Hi friends, welcome to Shraddha Tutorials. Today I am going to solve first problem of first exercise from real numbers of class 10. Okay, here what is the first problem? See, by using Euclid's division algorithm, we have to find the HCF of 135 and 225, 196 and 38,220, 867 and 255. Okay, so before going to find the HCF of the given values, now let us know what exactly a Euclid's division lemma is. Okay, if there exist or if there are two positive integers a and b, then there exist unique pair of integers q and r which satisfies a is equal to bq plus r. Here a is dividend, b is divisor, q is quotient and r is remainder. See here, in a is equal to bq plus r will be always greater than or equal to 0 but less than b, that is divisor. Okay, na? Yes. Now let us apply Euclid's division lemma to solve the first problem. Okay, see here a and b they have given, but always a will be greater than b, and so here a value is 225 and b value is 135. Okay, now applying Euclid's division lemma on a and b, that is a is equal to 225 and b is equal to 135. Okay, so let us write this stepwise. Okay, now step 1. So we have to represent in the form of a is equal to bq plus r. Here we know the value of a is 225. 225 is equal to bq. So b into q. So b is there. How much is q? We don't know. Okay. So of course these two values are smaller values. So directly I can write here. But sometimes it's not possible. For an example, if you go for second problem, it's not that much easy to solve directly by writing in a statement way. So we have to go for long division method. That is, we have to go for rougher. Okay. Yes. Let me divide 225 with 135. So how many times you can? 135 means 135 ones are 135, and you will be getting the remainder 90, which is not equal to 0. Okay. Now here, to find the HCF of the given values, you have to go for continuation, in the sense like see here the remainder is not equal to 0, then we have to take this remainder as a divisor and this divisor as a dividend, and you have to go for again a division. Okay, till you get the remainder 0. Okay, so here since we didn't get remainder 0, then we have to go for second step again. Okay, so we have to repeat same step. Now see, a is equal to bq, b is there, what is q? 1, so 135 ones and the remainder is 90. So since r is not equal to 0, repeat above step by taking a is equal to 135, means the value of b will become a in the next step and the value of r will become b, okay, in the next step. A is equal to 135 and b is equal to 90. So what is the step 2? So step 2, in step 2, 135 is equal to, means a is equal to b into, means 90 into, actually here one time, 90 ones are 90. If you go for 92s, you will be getting 180, which is greater. Okay, now so let we do here long division method. 90, 135. So we can't go for 2 times, so 90, and the remainder is 45, which is not equal to 0 again. Okay, so how to write? 135 is equal to 90 into 1 plus remainder is 45. So here again remainder not equal to 0, we have to repeat this step again. So by taking a value as 90 and a b value 45. So same step, repeat here. Since r is not equal to 0, repeat above step by taking a is equal to 90 and b is equal to 45. A is equal to 90 and b is equal to 45. Then how to write in step 3? Step 3. See, 90 can be written as 45 into 2. 45 2s are 90 and the remainder will be 0. Now directly you can write since r is equal to 0, b is equal to 45. B is equal to 45 is HCF of 135 and 225. 135 and 225. If you have any doubts, just pause the video and just you go through the steps once, or otherwise rewind once and just you go through once. Okay, yes. So this is the procedure to solve the first problem, and let me go for a second one. Okay, now B. Okay, so 196 and 38,220. Here A is large value, that is 38,220, and B is 196. Now we have to applying Euclid's division lemma on A is equal to A is equal to 38,220 and B is equal to 196. See here, it's not that much easy to write in statement. So we have to go for long division method. Why? Because one is a small value and one is too big. So we can't say directly what would be the exact factor, so that if you multiply with 196 you will be getting 38,220. Maybe you may get here exact factor directly, or otherwise if not, if you don't get in first step, you have to go for another step. Okay, no? Yes. So now let me go for a long division method. 38,220 divided by 196. See, 196 one time once, 196 once is one time is 196. See, if I go for 196 two times, then I will be getting something like 392. 392 is greater than 382, so we can't subtract. So for that reason, one time, so 196. So how much I will be getting here? 12 minus 6, 17. So 7 you will be getting here. If I carry 1 here, 17. 17 minus 9, I will be getting 8. Then 2 minus 1, yes, 186. If I carry down 2 here, then see, this is near to 1900 and this is near to 200. If I go for 10 times, it will become 2000. So something like 200 into 10 times 2000. So 2000 is greater than 1900. See why? Because this is near to 19. So if I go for 9 times, then I will be getting 1764. So if I subtract, I will be getting here 8. 12 minus 4, 8, and here 5, so 15. 15 minus 6, 9 I will be getting here 7, 7 minus 7, 0, 1 minus 1, 0. Okay, so if I carry down this 0, then 196 5s, you will be getting 180, and the remainder is 0. So here directly we got the remainder 0 in first step itself. So we can consider 196 as the HCF of 196 and 38220. Okay, now so how to write? So now A, that is 38,220 is equal to B into Q plus R. What is B? 196 into what is Q? 195 plus R. What is R? 0. Since R is equal to 0, B is equal to here 196, isn't it? 196 is HCF of 196 and 38,220. So here to this problem, in first step itself we got HCF. Okay, now third one, that is 867 and 255. Okay, yes. How to solve? First we have to take A, big value, that is 867, and B, that is 255. So what we have to do? We have to applying Euclid's division lemma on A and B. Now let me divide 867 with 255. How many times it can? 3 times 765. If I get 765, the remainder is something like here 7 minus 5 2, 6 minus 6 0, 8 minus 7 1, isn't it? So remainder is not equal to 0. So step 1, how to write? Step 1, A has to be represented in the form of BQ plus R. What is B? 255. 255. BQ. B into Q. What is Q here? 3. So plus. So 255 3s are 765, and the remainder is 102. If you add 102 to 765, you will be getting 867. Okay. So since R is not equal to 0, repeat above step by taking A is equal to 255 and B is equal to 102. Okay. So how to write step 2 then? Step 2 is 255 can be written as 102 into how many times? 102 into Q value. So here, see, since R is not equal to 0, we have to go for another step, that is taking remainder as divisor and divisor as dividend. So how many times? 2 times. So you will be getting 204 and the remainder is 1 and 5, 51. So again remainder is not equal to 0. So how to write this? Plus 51. 102 or 204. 204 plus 51 is 255. Okay. Same. Since R is not equal to 0. Since R is not equal to 0, repeat above step. Above step means this step again. Above step by A is equal to now 102. B is equal to 51, that is remainder. Okay. Now let me go for again here division one more time. 51 and here dividend will be 102 as we discussed earlier. So 2 times 51 2s are 102. So the remainder is 0. So here the remainder is 0. So let me write in step 3. So step 3. In step 3 102 has to be written as can be written as 51 into 2. 51 2s are 102. So the remainder will be 0. So since R is equal to 0 here, B is equal to 51. B is equal to 51 is HCF of 867 and 255. 867 and 255. Okay. I hope you all understood the content what I have discussed in this video. Thank you for watching this video. Thank you very much.